Earlier, last time we have started Born-Haber cycle, right?
Yes, sir.
Okay. So we have discussed uh, 5 cases, right?
Yes, sir. You also give a homework last class.
Okay, this is your homework, right? Now, can you tell me how to create Al2O3's Born-Haber cycle?
Sir, should I send you the picture on WhatsApp?
Yes, 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 yes. It's better. But have you sent?
Yes, sir. I've sent.
Okay. You have 2 aluminum, so 2Al, 2Al, 2L plus 1, 2L plus 2, 2L plus 3. So H1 is 2 times H1, right? H1 is 2 times H1. Beta, are you getting my point?
Yes, sir. Okay.
Because you have 2 aluminum.
So, sir, then the electron affinity will also be multiplied by 3.
Yes, but if electron affinity is also multiplied by 3. Yes. So 3 minus 1, 3 minus 2. Yes. H6 multiplied by 3, H7 multiplied by 3. H8 is latest energy. Very good. L2O3 solid. So another mistake is Al2O3 is nearly equal to a aluminum and oxygen. It should be near the H9. Are you getting my point?
Okay, sir.
So now we are moving to Born-Haber cycle numerical, right? Okay. Now the first question. It's past paper question, right? 2002 October November variant paper 4 question number 2. Yes. Can you tell me latest energy equation?
Sir, 2 Na plus gaseous.
2 Na plus gaseous. Okay. Then
Plus O2 minus gaseous.
plus O2 minus gaseous. Very good.
Gives Na2O solid.
Gives Na2O solid. Yes. Now you have Born-Haber cycle, right? You have Born-Haber cycle. Now identify species A and B. Yes.
So it can be 2 Na gaseous.
Mm-hmm. Yes. Then
And then B is just O.
now,
O gaseous.
okay, O gaseous. Now two, you have 2 Na solid, right? So first you convert 2 Na solid into 2 Na gaseous, right? 2Na gaseous. 2Na gaseous. Then you convert half O2 into O, gaseous. This is when you remove one electron. So are you getting my point or not? This is
Yes, sir.
atomization of sodium. Atomization of sodium. This one is 2 times, right? And this is ionization energy of sodium, but again 2 times. This is atomization of oxygen. Can you tell me what is 2?
Sir, 2 times electron affinity of oxygen.
2 times or sum of first and second electron affinities.
Yes, sir. Sum of first and second.
Sum of. So 2 is first electron affinity plus second electron affinity. 3 is lattice energy. 4 is formation, right? Now move to the question. Now can you tell me what is the species A?
Sir, 2
Only
Na
species.
gaseous.
Only species, right? It's not asking the number. So it is Na gaseous. Okay. And what about species B?
It's O gaseous.
O gaseous. Very good. Now tell me what is 1? Yes, what is 1?
So it's the first ionization energy of Na
It is the first ionization
times
energy of Na, right? First ionization energy. First ionization energy of Na. And what is 2? You can say that 2 times, right?
Yes, sir. 2 times.
What is 2?
So it's the electron affinity of oxygen. First and second group.
2 is first and second electron affinity of oxygen. And what is 3?
So lattice energy
Okay, lattice energy
of Na2O.
okay, lattice energy of Na2O. And what is 4?
It's enthalpy formation of Na2.
Okay. Enthalpy of formation enthalpy of formation of Na2O. Na2O. This is 2002 October number, right? Now question number 3 from 2004 May June. What is lattice energy? Yes.
So it's the energy change when an ionic compound is formed from its gaseous ions. Like when 1 mole of ionic compound is formed from its gaseous ions.
Okay. Energy change when 1 mole of solid compound is formed from its gaseous ions. This definition is for 2 marks, right? So this is for 1 mark, energy change, 1 mole, and second mark for gaseous, from its gaseous, right? So this question is for 2 marks. Yes, latest energy of magnesium chloride. Yes, beta.
So Mg2 plus gaseous
Mg2 plus gaseous,
plus 2Cl minus gaseous
2Cl minus gaseous
gives MgCl2 solid.
gives MgCl2 solid. Correct. Now comparison of lattice energy. Now comparison of lattice energy. You are comparing magnesium chloride and NaCl. Magnesium chloride and NaCl. This is magnesium chloride. This is NaCl. Right? Can you tell me which element is cancelled out?
So the chloride ion.
Chloride ion is cancelled out. Now you have magnesium plus 2 and Na plus 1. So always remember this is Di, doctor instruction. Lattice energy is directly proportional to charge. Charge of cation and anion. Charge of cation and anion. This is Di. Di means doctor instruction, short keys, right? So can you tell me which one has more charge?
So magnesium.
Magnesium has more charge. So lattice energy of magnesium chloride is greater than lattice energy of NaCl. Why? Because magnesium has more plus 2 charge than sodium plus 1. A strong electrostatic force of attraction between magnesium and chlorine than sodium and chlorine minus 1. Can you repeat the answer? 3 points. I need 3 points. Alia, can you repeat?
So the charge of magnesium is greater than the charge of sodium.
No. First state the which one has the more lattice energy.
So magnesium has more lattice energy.
MgCl2, right?
MgCl.
MgCl2 has more lattice energy, right? Or lattice energy of MgCl2 is greater than lattice energy of NaCl. Why?
because it has greater ionic charge.
Because it has
2 plus.
more charge, right?
Mm.
Plus 2 charge. So as the charge, as more charge, more attraction between Mg plus 2 and Cl negative, then Na positive and Cl negative. So lattice energy of MgCl2 is greater than lattice energy of NaCl, because magnesium has more plus 2 charge than Na plus 1. So another point you can write, strong if this question is for 3 marks, right? Strong electrostatic force of attraction between Mg plus 2 and Cl minus, then Na positive and Cl negative. This is for 3 marks, right? First, lattice energy is greater. Second is because, and third one is strong electrostatic force of attraction. Now, comparison between magnesium chloride and CS magnesium chloride versus CaCl2. Now, which element is cancelled out?
So chloride ion.
Chloride. Now you have magnesium plus 2 versus calcium plus 2. Now, which factor is cancelled out?
So ionic charge is the same.
Charges. They have same charges. Now, the only factor is size. Only factor is size. Now, Di, another Di. Lattice energy is inversely proportional to size of cation and anion. Now, you have these elements: beryllium, magnesium, calcium, strontium, barium, radium. So which one has a smaller radius?
So beryllium.
No. Between magnesium and calcium, which one has a smaller radius?
So magnesium has smaller radius.
So magnesium has a smaller radius. So lattice energy of magnesium chloride is greater than lattice energy of calcium chloride, because smaller size, more lattice energy. More charge, more lattice energy. You have only 2 factors, right? Always remember, charge is dominating factor. Charge is dominating factor. So next is lattice energy of MgCl2 is greater. Lattice energy of MgCl2 is greater than lattice energy of calcium chloride. This is for 1 mark. Why? Second mark, because magnesium plus 2 is smaller than Ca plus 2. For 3 marks, you have to write this point. For third mark, distance between magnesium plus 2 and Cl minus is smaller than calcium plus 2 and Cl minus. Last point, strong electrostatic force of attraction between magnesium plus 2 and Cl minus, then Ca plus 2 and Cl minus. These points are maximum points, right? For this question is for 2 marks. So blue one is the correct answer, accurate answer for 2 marks. For more marks, you have to increase the answer. You can write the distance. You can write the electrostatic force of attraction. Beta, are you getting my point or not?
Yes, sir. I'm getting it.
Okay. Now, numerical of lattice energy. Numerical of lattice energy. Now, I am trying to form another time lattice energy of sodium chloride. You have sodium solid. First, you convert sodium into sodium gaseous. Can you tell me what is this? What is the name of the energy?
So atomization
Just
of
can you tell
sodium.
me the, okay, can you tell me the value?
107 kilojoule per mole.
107. Okay. Now convert into Na positive gaseous, right? Na positive gaseous. So do you have ionization energy? Yes, you have. Can you
Yes, sir.
tell me what is,
490.
yes, 494. 494. Now next, chlorine, Cl2 gaseous. So you need only one. So divided by 2. Cl gaseous. Can you tell me the name of this energy?
So atomization of chlorine.
Can you tell
122.
me? 122 is given. 122. 122. Now, sodium positive gaseous and then Cl negative gaseous. Yes. What is this?
So electron
Yes.
affinity of chlorine.
Yes. This is,
Minus 349.
okay, minus 349. Now join these two. This is H5. Yes. Can you tell me the value of H5?
So we have to find the value of H5.
We have to find it. So it is X. Now join these two. Can you tell me the name of this H6?
So it's the formation of
Formation,
NaCl.
and
So
it's
minus 411.
411, right? So according to formula, H6 is equal to H1 plus H2 plus H3 plus H4 plus H5. Now, can you tell me the answer? While H1 is 107, H2 is 494, H3 is 122, H4 is minus 349, H5 is required, H6 is minus 411. Can you tell me the value of X?
So minus 785.
So minus 785 kilojoule per mole is your answer. Minus 785 kilo, sorry, minus 785. Now, 2023, May, June, within 42, very latest question. Yes. Yes. Can you tell me about the bond energy? Bond energy is endothermic, exothermic. Yes.
Sir, it can be both.
No. Bond energy is always endothermic. It is the amount of energy required to break 1 mole of a bond in gaseous state. So it is the bond energy is endothermic. Bond energy is endothermic. So can you tell me the answer? Always positive, always negative?
So always positive.
Always positive. Always positive. Yes, can you tell me now? Remember, this is 42 variant, right? Yes. Atomization,
So endothermic.
endothermic. Atomization, it is the amount of energy or it is the enthalpy change when 1 mole of gaseous atom is formed from element in its standard state. So endothermic, positive. And what about the formation?
So always negative. It's exothermic.
Always negative, right? So I have a chart, right? Uh, Always negative formation.
So energy is released.
No, for formation, sometime exothermic, sometime endothermic, right?
But sir, how?
Because sometime uh, bond breaking is greater, sometime bond forming is greater. That's why sometime bond formation is endothermic, sometime bond formation is exothermic. It depends on the bond breaking and bond forming energy, as you have studied in AS chemistry. Are you getting my point or not?
No, okay, sir. Getting it.
So I have a complete note of it. A2 chemistry. Yes. Yes. Beta, this is the table, right? You can take a screenshot, right? So which one is exothermic? Which one is endothermic? It is completely written in it, right?
Okay, sir.
Formation is written, reaction is written. Bond energy is not written, right? So here we have bond energy. Bond energy is endothermic. Beta, are you getting my point?
Yes,
Beta,
sir,
can I
getting.
okay? Can I move to again past paper?
Yes, sir, sure.
Okay. So yes, here we have. Yes. Define standard enthalpy change of atomization for 2 marks, right? Did you remember this definition?
Yes, sir. So the
Yes.
enthalpy change in one mole of gaseous atoms is formed from its element under standard conditions.
Very good. Enthalpy change when 1 mole of gaseous atom is formed. Gaseous atom. You know that gaseous atom is called ion, right? Gaseous atom is formed. One number two, from its element. From its element in standard state. In its standard state. For example, if you have hydrogen, so hydrogen it should be in gaseous form. If you have carbon, carbon is graphite, so it must be solid. Standard state. You can also write standard condition, right? Standard condition means 298 Kelvin temperature and 1 atmospheric pressure. Now, Born-Haber cycle. Again, same question, right? Now we have Ag2O. Now we have Ag2O. Now let's start from the silver. Silver solid. Can you tell me how many silver atom do you have in this question?
So two
2.
atoms.
So multiply by 2. Multiply by 2. So convert 2 silver into 2 Ag gaseous. Can you name this energy?
So atomization of silver.
2 times atomization of silver. Can you tell me the value of atomization of silver?
So 285 times 2.
285 times 2. 285 times 2. Okay. Then, yes, beta, then
So then 2 Ag plus gaseous plus 2 E
2
negative.
Ag plus gaseous, right? So here minus 2 electron, right? So this is H2. Yes. Can you name this energy?
So 2 times first ionization energy of
2
silver.
times first ionization energy of silver. Yes. Can you tell me the value?
So 2074.
Hmm?
So 731.
731. 731. Okay. Now, oxygen. How many oxygens are given in your question?
So 1 oxygen.
1 oxygen. So you have to divide it by 2. So here we have 1 oxygen. Oxygen gaseous. Yes. What is this?
So atomization of oxygen.
Atomization of oxygen. Now, Look at the atomization of oxygen is given or not given?
So it's not given, so we lose the bond
It's not
energy.
given. Exactly. Can you tell me the formula? Bond energy?
Divide by 2 times 1.
2 times 1. Now, can you tell me the bond energy? Oxygen-oxygen double bond or oxygen-oxygen single bond?
So single bond.
No, oxygen-oxygen double bond. Oxygen is always double bonded.
But so there's only one oxygen in our equation.
No, you will consider this one. This is atomization. This is not atomization. This is atomization. So O double bond O is broken. Are you getting my point?
Okay, sir.
So 496 divided by 2 multiplied by 1. Now next. Now 2 times Ag and O minus 1 gaseous. So 1 electron is added here. Now can you tell me the value or what is this? What
So
is
it's the
H4?
first electron affinity of oxygen.
First electron affinity of oxygen. Is it given?
So minus 141.
141. Okay. So second electron affinity is upward because it is because of the repulsion between the upcoming electron and negatively oxygen. This is H5. As a result, silver remain intact with oxygen and oxygen become
Sir, I have
minus
a
2.
question.
Yes, yes. Yes, Peter.
In the bond Haber cycle, do we need to be careful about the length of the arrows?
No. Neglect it. Neglect. But direction is important. Length is not important. Direction is important. Upward arrow means endothermic, downward arrow means exothermic.
Okay, sir.
Okay, can you tell me the value of H5?
So plus 798.
Plus 798. Now join these two. You have Ag2O solid. This is H6. Can you tell me the value of H6?
So it's just X.
Okay, you have to find latest energy. Next, H7. Yes,
So it's the formation, so minus 31.
minus 31. So H7 is formation. Now, can you tell me the formula?
So sir, H7 is equal to H1 plus H2 plus 3
Very
whole
good.
5
Very
6.
simple. H7 is equal to H1 plus H2 plus H3 plus H4 plus H5 plus H6. Yes. Now, can you tell me what is H7? Minus 31.
So minus
What is H1? 2 times 285. What is H2? 2 times 731. What is H3? 496 divided by 2 multiplied by 1. What is H4? Minus 141. What is H5? 798. What is H6X? Now, can you tell me the value of X?
so minus 2968.
Minus 2968. Minus 2968 kilojoule per mole. minus 2968 kilojoules per mole. Now compare. Beta, can I move forward?
Yes, sir.
Okay. Now you have Ag2S, Ag2O, Ag2Se. Now look at the periodic table and tell me either they. So which element is cancelled out? Silver,
Sir,
silver,
Ag2.
silver. Right? So sulfur is -2, oxygen is -2, selenium is also -2, right? Are they belong to group 6?
Yes, sir.
Okay, they all belong to group 6. 16, sorry, 16. So first oxygen, then sulfur, then selenium, then tellurium, then polonium, then livermore. This is group 16. So which one is smaller?
The oxygen is smaller.
Oxygen is smaller. So which one is more exothermic? Smaller releases more energy. Smaller size, big release energy. More exothermic, more negative. So which one is more negative? Which one is more exothermic?
The oxygen, sir.
So Ag2O is more exothermic. Then which one is the
Then
larger one?
the largest is selenium.
Selenium. So AgSe, Ag2Se. And in the mid we have Ag2S. Now you have to explain. Yes.
So,
Yes,
sir,
can
in
you explain?
Ag2O, the ions are farther apart in the lattice, so the electrostatic forces of attraction will be weaker.
Okay. So it's all depend on the size of the ion, negative ion, right? So Se minus 2 has largest radius oxygen minus 2 has smallest radius. So distance between selenium minus 2 and silver plus is larger than O minus 2 and silver. Hence, is weak electrostatic force of attraction, weak electrostatic force of attraction between Ag positive and selenium negative, then Ag positive and O minus 2. Beta, are you getting this point?
Yes, sir.
Can I move forward?
Yes, sir.
Okay, now 2023 May June variant 42. Again this table. Now tell me latest energy. Yes,
So
beta.
always negative.
Latest energy is always positive, negative.
Negative, sir.
Always negative. Very good. And what about hydration? No. Now listen. Now listen. What is hydration? We have studied in AS chemistry, right? Do you know what is hydration? What is solution? We have studied in AS chemistry.
So I don't remember actually.
Okay, now listen. As for solution, as for solid, whenever you add water in solid, aqueous ions are formed. This energy is called enthalpy of solution. Whenever you add water in gaseous ion, aqueous ions are formed. Such enthalpy is called enthalpy of hydration. Enthalpy of hydration. Now, always remember, I am your sir. Sir is sometime positive. Sir is sometime negative. For positive student, sir is always positive. For negative student, sir is always negative. So it sir may be positive, may be negative. So solution is start from S. So may be positive, may be negative. Hydration is always endothermic, exothermic. Are you getting my point or not?
Okay, sir. I'm getting it.
S solution is sir may be positive, may be negative. Hydration is always negative. So what is hydration? Yes. Tell me what is hydration?
So it's when aqueous ions are formed from the solid ion.
No, from gaseous sign. From gaseous sign. Now look at here. Look at here. Always remember my DI. DI is very, very important. Whenever you have gaseous ion, solid is formed. This is called latest energy. This is called latest energy. When water is added in gaseous ion, when water is added in solid ion, when water is added, when water is added in solid, as for solid, aqueous ions are formed. As for solid, as for solution, as for solid, as for solution. This is called enthalpy of solution. This is called enthalpy of hydration. Now, it is quite easy to memorize. From gaseous ion, ionic solid is formed. It is latest energy. Now, add water in both of them, right? Whenever you add water in gaseous ion, aqueous ions are formed. It is called hydration. When you add water in solid, when you add water in solid, when you add water in solid, aqueous ion are formed. This is called enthalpy of solution. Beta, are you getting my point or not?
Oh, yes, sir. I'm getting.
Okay. So can you tell me definition of the hydration?
So it's when water is added to gaseous ion to form an aqueous ion.
Hmm. Can you repeat?
So water is added to 1 mole of gaseous ions to form aqueous ions under standard conditions.
Yes, but when water is added, Are you getting my point? Whenever water is added in aqueous ions are formed, enthalpy is released. This enthalpy is called hydration. Can you repeat this definition again?
So when water is added to gaseous ions, it forms aqueous ions and energy is released. So it's called enthalpy change of hydration.
Okay, and what is solution?
So it's when water is added to the solid to form an aqueous ion, and then the energy which is released is called enthalpy change of solution.
Okay, now look at the definition, right? Enthalpy change when 1 mole of gaseous ion dissolves in water to form dilute solution, or you can write aqueous solution, is known as, it is not standard, right? Standard is not written. In definition, standard is not written. So no need to mention standard condition, known as, are you getting my point or not?
Yes, sir, I'm getting it.
Enthalpy change of hydration. Now you have numerical, right? Question is about calcium bromide. Latest energy is required, right? Now I am starting. This is, you have calcium solid, then convert calcium gas, then calcium plus 1 gas, then calcium plus 2 gas. Here remove 1 electron, here remove 1 electron. This is H1, this is H2, and this is H3. Yes, can you tell me what is H1?
So atomization of calcium.
Yes, look at the table data and tell me the value.
So it's not there. No, so 178.2.
178.178.2. 178.2. Now what is H2 and H3?
So first ionization energy of calcium and second ionization energy of
Yes,
calcium.
what are the values?
So 590 and 1145.
590 and 1145.
45.
Okay, 1145. Now second is bromine. Br2 gaseous. So how many bromine? 2 bromine. So no need to divide it by 2. Now Br, 2 Br gaseous. This is H4. Yes, can you tell me the value of, what is this H4?
So atomization of bromine.
Can
Two
you tell
times
me the value? 2 times, very good. Can you tell me? Either it is given or not. If not given, bond, you can use bond energy. Bond energy divided by 2 and multiply by the number which is coefficient with the bromine.
So sir, it's a 111.9.
Is it given?
Yes, sir, they gave it.
Okay, atomization of bromine is given. Where is atomization of bromine? Yes. 111.9. So 111.9 is given. Now downward we have calcium plus 2 gaseous, 2Br negative gaseous. Can you tell me its value? So
13 times per
I have committed one mistake in atomization of bromine. Can you tell me what? I have committed one mistake in H4. Atomization of bromine is
You have to
111.
multiply it by 2.
You have to, yes, exactly, multiply by 2. Because here we have 2 bromine atom. So H5. H5 is electron affinity of bromine.
So sir, minus 324.6 times 2.
Okay, minus 324.6 times 2. So second electron affinity is also given. Is it useless?
Yes, sir.
Yes, because bromine is minus 1.
Sir, is it possible for bromine to have a second electron affinity?
Yes, possible. Yes, you have possibility, right?
But
But
the charge
in
is
this
only
case,
minus 1.
if the formula of calcium bromide is CaBr, it means you have Br minus 2. But here you have CaBr2. Are you getting my point, beta?
But sir, isn't the charge for bromine fixed?
No. Bromine is, you know that only fluorine is always negative 1, while other has variable valencies. Only fluorine is always minus 1.
Okay, sir.
This is H5, latest energy. Can you tell me the value of the latest energy?
So we have to find it, so it's X.
Okay, X. This is calcium bromide solid. This is H6. H6 is formation of CaBr2. Yes, can you tell me the value?
So minus 682.8.
Sorry, can you tell me again? Minus
Minus 682.8.
682.8. Now, can you tell me the formula?
So sir,
Yes.
H6 is equal to H1
Very
plus
good.
H2 plus
H1,
4.
H3 plus H4 plus H5. Now, H6 is minus 682.8. H1 is 178.2. H2 is 590. H3 is 1145. And H5 is 2 times minus 324.6. H5 is required. Now tell me the value of X.
So minus 2170.6.
Minus
2170.6.
minus 2170.6 kilojoule per mole. Minus 2170.6 kilojoule per mole. Correct answer. Now look at the question number 2, second part. Calculate the instant enthalpy change of hydration. Hydration is required. Lattice energy is given. Now check hydration is given in the question.
So hydration of calcium is given.
It means you need hydration of bromine also. Now look at the table and look at the question. Hydration is given or required?
So it's required.
Hydration is required. So formula for hydration and lattice energy and solution is that hydration is equal to lattice energy plus solution. Hydration is equal to lattice energy plus solution. Are you getting my point or not?
Yes, sir.
Hydration is equal to lattice energy plus solution. Now your salt is calcium bromide, right? This is extra support, right? This is now you have calcium plus 2 gaseous, 2Br negative gaseous. When you combine these two, it is called lattice energy. Calcium bromide solid is formed. Can you tell me the value of the lattice energy?
So minus 2170.6.
Minus 2170.6. Now water is added in it. Now water is added in it. This is calcium plus 2 aqueous. Aqueous ions are formed. This is called as for solid. Alia, this is solid. As for solid, as for solution.
Yes, sir.
Yes. Yes. Can you tell me the value of solution?
So I will use a table to find it.
Yes. Look at the table.
So minus 103.1.
Minus 103.1. Minus 103.1. And this is hydration. So hydration of calcium is given, right?
Yes, sir.
So calcium hydration is given, which is yes,
So minus 1579.
minus 1579. Minus 1579. 2Br is required. So 2x is required. Are you getting my point or not?
Yes, sir.
So formula is hydration is equal to lattice energy plus solution. So hydration of calcium plus hydration of Br minus, but 2 times, is equal to latest energy plus solution. This is minus 1579. This is plus 2x. Latest energy is minus 2170. Plus solution is minus 103.1. Now, can you tell me the answer of x?
So minus 347.35.
Can you repeat it? Minus 3, 4,
Minus 347.35.
0.4 kilojoule per mole. Minus 3, 4, 7.4. Okay. Now, third part. Enthalpy change of hydration of Br minus is more negative than enthalpy change of hydration of I negative ion. Explain why. Now, always remember latest energy, hydration, solution, all have same factor, charge and size. Charge and size. Charge and size. So can you tell me which one has more charge, or which one has more charge?
The charge is the same.
Charge is the same. So only factor is size. So fluorine, chlorine, bromine, iodine, astatine. Yes, which one is smaller?
So bromine is smaller.
Bromine is smaller. Bromine is smaller. So which one has more hydration?
So bromine will have more hydration.
Bromine will have more attraction, right? So the answer is size of Br negative is smaller than I negative. Distance between, this is hydration. So hydration means water. Distance between Br negative and H positive of H2O is smaller. Strong electrostatic force of attraction between Br negative and with water molecule. Peter, are you getting this point or not?
Yes, sir, I'm getting.
Now this one is May June variant 23, question number 1. Define latest energy. Yes.
So enthalpy change when 1 mole of ionic compound, 1 mole of solid compound is formed from gaseous ions under standard conditions.
Under standard condition. Okay. So this is 9701 for the question number 1, right? Yes. What is latest energy? Can you repeat it again?
So it's the enthalpy change when 1 mole of solid compound is formed from gaseous ions under standard conditions.
Enthalpy change or released. Enthalpy change when 1 mole of ionic solid is formed. This is for mark 1. For second mark, from gaseous ion, from gaseous ion, from gaseous ion. For example, Na positive gas plus Cl negative gas, NaCl solid is formed. Now look at the second part, right? The lattice energy of group 2 carbonate become less exothermic. Less exothermic means less. Less. The lattice energy of group 2 oxide also become less exothermic. Lattice energy of M carbonate and lattice energy of oxide change by different amounts going down the group. So it means the factor is size. Down the group means size increases. As the size increases, lattice energy decreases because size is inversely proportional to lattice energy. Beta, are you getting my point?
Yes, sir, I'm getting.
Suggest how the standard enthalpy change of the decomposition reaction for group 2 carbonate changes down the group. Explain your reasoning in terms of relative sizes of the anion and the relative charges changes in lattice energy down the group. Yes, this is from the AS chemistry. Yes,
So
Vijay.
enthalpy change of decomposition increases down the group.
Okay. Now this is for 2 mark, right?
Yes, sir, too.
So decomposition become more positive or less negative? Yes. Yes. Can you tell me the decomposition?
So it will become decompose. So the enthalpy change of decomposition will increase down the group.
Mm. Can you tell me the lattice energy increases or decreases down the group?
So lattice energy is decreasing.
Lattice energy decreases. So if lattice energy decreases, salt becomes stronger or weaker?
As it becomes weaker,
Weaker. So decomposes easily or not easily?
so it will decompose easily then.
So decomposition increases, decreases,
So it will decrease, sir. Not decrease.
decreases. So decreases.
Yes, sir, because it's becoming weaker to compound.
So decompose. So energy required become less.
Yes, sir.
No. As you know that for decomposition we have 2 factors, right? Polarizing power of cation, polarizing power of cation, and distortion of anion. Have you remembered ACE inorganic group 2?
Yes, sir. Group two.
As we go down, as we move down, size of the cation, group 2 cation increases. Polarizing power decreases. As
So
we
what's
move,
the polarizing power?
polarizing power means to distort the shape of the anion. cation has the capability to change the shape of anion.
Okay, sir.
Now look at here. This is Di. This is calcium, or this is beryllium. Beryllium plus 2 is smaller. Here we have carbonate. So beryllium is smaller. It has more distortion power. So the shape is changed. Now you can change, you can see that shape of carbonate is changed. This is called distortion. This distortion is due to the polarizing power of cation. Why high polarizing power? Because it is smaller, high charge density. It has more power to attract lone pair. So due to the attraction of positive nucleus, anion distorted. Now less energy is required. Are you getting my point?
Okay, sir.
This is called distortion. Distortion. And this positive has more polarizing power. It has more polarizing power. So beryllium has more polarizing power while carbonate is distorted. So less energy is required. Less energy is required. Now in the end, because of the distortion, beryllium oxide and carbon dioxide are formed. Oxygen is removed easily. So down the group, more energy is required to decompose carbonate. Beta, are you getting my point or not?
Okay, sir.
Now you can see that latest energy is given. Latest energy is less exothermic, right? So this is for 2 marks. Change of decomposition. Standard enthalpy change of decomposition. Standard enthalpy change of decomposition. Yes, standard enthalpy change of decomposition increases. Increases means more positive. More positive means more endothermic. More endothermic. Or less negative. All statements are correct. Down the group. Why? Because down the group, polarizing power of cation decreases because size increases. Decreases. Distortion of anion decreases. That's why down the group, standard enthalpy change of decomposition increases. Beta, are you getting my point or not?
Yes, sir, I'm getting.
Okay. And what about the oxide? Latest energy of oxide. This is
So
for
latest
carbonate,
energy will
right?
decrease down the group.
Sorry.
So latest energy will decrease down the group, right?
Okay. So what about the size of the oxygen? Size of the oxygen, oxide ion and carbonate ion. Which one has a smaller radius? Oxide or carbonate?
So oxide.
Oxide. So second point is size of O minus 2 oxide is smaller than size of carbonate. Size of carbonate. So which one has more latest energy? Oxide or carbonate?
Oxide, sir.
Okay. So which one is, you know that latest energy is exothermic, right? Latest energy is, are you listening my voice?
Yes, sir, I'm listening.
So which one is faster?
So carbonate will be easily decomposed.
Carbonate will decompose easily. Now, can you find through the from the Google which one has more latest energy? Calcium oxide or calcium carbonate? Are you listening my voice?
Yes, sir, I'm googling it.
Which one is smaller? Oxide or carbonate?
So oxide is smaller.
So which one has more latest energy?
So oxide will have more latest energy.
Oxide, because the size is smaller, right? So which one is more exothermic?
So oxide is more exothermic.
Now find from the Google. Calcium oxide is more exothermic or calcium carbonate? So we have discussed size.
So
We
it
have discussed
seems
latest energy.
endothermic thermal decomposition.
Thermal decomposition is always endothermic, right? Now I am asking which one has more latest energy, calcium oxide or calcium carbonate?
So calcium oxide.
Can you tell me the value from the Google?
Minus 3460.
Minus 3460. Are you minus 3460?
Yes, sir.
And what about the calcium carbonate?
So 2800.
2000 minus 2800. Huh?
Yes, sir, ma'am.
So which one has more latest energy?
Calcium oxide, sir.
Calcium oxide. So third point. So oxide has more latest energy, more negative, more exothermic than carbonate. Now, read the question again. Read the question again and read the answer again. Question was that suggest how the standard enthalpy change of decomposition reaction for group 2 carbonate changes down the group. So increases. Explain using in terms of relative size of anion and the relative changes in lattice energy down the group.
So the compounds, as they go down the group, they become less stable.
More stable. Thermally more stable because beryllium, magnesium, calcium, they are smaller. So because of smaller, charge density is more. So distortion is more. So if distortion is more, less energy is required to distort the anion. Oxide, beryllium oxide is easily formed.
Okay, sir.
Lattice energy of group 2 carbonate become less exothermic down the group. So it is stated that less exothermic. Less exothermic means less energy is released. Similarly, lattice of group 2 also become less exothermic down the group. So both decreases. So carbonate and metal oxide change by different amount going down the group. Suggests how the standard enthalpy change of decomposition reaction for group 2 carbonate changes down the group. Explain your reasoning in terms of the relative sizes of the anion and the relative changes in lattice energy down the group. Right? Are you getting this question?
Yes, sir, I'm getting.
Okay. So this is all about the lattice energy and hydration solution. So inshallah, in the next class, we will do more questions from the past paper, right? After completion of the chapter, I will send you 2 files, right? One, written notes. Number 2, this past paper solution. Are you getting my point?
Okay.
After the completion of the chapter, right? I have my notes also. Yes, this is right. So I will send this file and the past paper file, right?
Okay, sir.
Okay, do you have any question?
Yes, miss.
No, sir, it's clear.
Okay, Allah Hafiz.
Okay, thank you, sir. Allah Hafiz.
Allah Hafiz.